Welcome back, Math 10 YouTubers. Mr. Tronis here, and we are going to kick off Unit 2 on factors and products. So let's get right into it. You're going to put Mr. T right there. Just kidding. Put your actual name. That's what I would recommend. This is a larger unit than last. We do have 8 sections. Some are a lot smaller than others, especially like 2.2, the divisibility rules. So let's just jump right into 2.1, multiplying polynomials, which is essentially just going to be review of Math 9. So let's bring it back. All right. What is a polynomial? So a polynomial looks something like this. We have 5x cubed minus 4x squared plus 7xy minus 8. Basically, we have 4 terms here, and they're separated by addition or subtraction. So one term, or the sum of terms whose variables have whole number exponents, okay? So no fractional exponents like we saw in the last unit. Okay, so let's talk about first, I did mention it already. We have 4 terms here. So I have one term here, a second term here, and notice I'm including the sign, and 4 terms. So our terms here, the first one is a 5x cubed. The next term is a negative 4x squared. The third term is a positive 7x times y. And our last term is just negative 8 all by itself. Okay, let's change colors here. And in green, I'm going to be labeling this special number at the end. It is used for a lot of different applications later on, and it's called our constant. So negative 8 is our constant. The constant is always going to be the term with no variables. Term with no variables. Now, you hopefully remember this, but if not, what am I talking about when I say variables? Well, variables are just symbols, usually letters like X and Y, that we use to represent unknown values. So these are letters that are unknown values. Okay, and they vary, they change, hence the name variable. And in this case, I have 2. I have X being used here, here, and here. So X is one of our variables. And another variable we see right here is the Y. So we have an X and a Y. We have 2 different variables in this polynomial. Finally, what are coefficients? Well, coefficients are always our numbers that are multiplying in front of our variables. Okay, so we have 3 coefficients in this example. So our coefficients here are positive 5, negative 4, and positive 7. And just to put a quick definition, what's a coefficient? Loosely, it's the numbers in front of variables. It's multiplying the variables, okay? Sometimes called a multiplier, numbers in front of variables. So one way to think of it is this represents 5x cubes and negative 4x squareds and positive 7xy's. All right. So, one thing I'll remember to add, it says it above, but terms are separated always by addition or subtraction. All right, now we got some special names for some of these polynomials. So we first will start with the most basic one is a monomial. Monomial, and that has just one term, okay? Next, we'll move up a term, and it's called a binomial. So this, of course, has 2 terms. And our last one we have is a trinomial, and that has 3 terms. So you remember those pretty easy. Monomial for 1, binomial, trinomial, like a bicycle is 2 tires, tricycle 3 tires. You get the idea. All right, anything above a trinomial, we're just going to call it a polynomial because we don't need to have fancy names for those ones, and they occur less frequently. In grade 9, you learned how to multiply a polynomial, okay, many different terms, with a monomial, a single term, like this example here. So I have a monomial, 2x, multiplying a binomial inside these brackets. Remember, this is multiplication in between here. And what we had to do is something called the distributive property. We're going to distribute this 2x by multiplying it by the 3x term and the negative 4x term. So let's do that. So we take our 2x in front and we multiply it by the second term. or sorry, the first term 3x, and then again we take our monomial 2x and we multiply it by the second term. Just be careful with signs because remember that term is a negative 4y. Now let's actually multiply these out. So now we're basically just multiplying two pairs of monomials. So combine like with like. It's just like our exponents unit before. 2 times 3 is 6. X times x is x squared. 2 times negative 4 is negative 8. In x times y, we can't combine them. They're different variables, so it's just xy. So now we have a result of 6x squared minus 8xy. Okay, what happens when things get a little more complicated? And your Math 9 teacher might have shown you some stuff like this, and they might not have because it is technically Math 10 curriculum. But first, I'm going to bring back, how do we multiply 26 times 31? Well, many, many years ago, probably grade 3-ish, you learned how to multiply two-digit numbers. And you were given a bit of an algorithm to do this. You'd set it up in their columns, and you would first start with the 1 here, and you'd go 1 times 6 is 6, 1 times 2 is 2. And then you were told to put a 0 here. Well, the reason for that is because now we have to multiply by 30, not 3, by 30 technically. But we just put the 0 there to save time. So now 3 times 6 is 18. We have to carry the 1 because now we have to go 3 times 2, which is 6, add the extra 1 for the 7. Now we have to add these two numbers together. 6 plus 0 is 6. 2 plus 8 is 10. Carry the 1 and we get 806. Now you were taught that a long time ago, but I'm going to show you something maybe a little bit different and it kind of helpful with mental math. I can take the 26, okay, and I can break it into 20 plus 6. Okay, nothing wrong with that. And I can take the 31 and I can break it into a 30 plus a 1. Okay, and now what this is saying, I now have two binomials. Sure, there's no variables right now, but that's okay. We can multiply this out. So how it works is what it's saying above is I have to take every term in this binomial and multiply it by every term in this. So we start with the first term, which is 20. We're going to multiply that by 30, and that's going to give us 600. Again, we're going to take the first term and multiply it by the second term now, and 20 times 1 is just 20. And let's switch colors to illustrate. Now I have to take my second term. So 20 has been multiplied by both of those. Now the 6 has to be multiplied with the 30 as well. And that's going to give me 180. And then the 6 needs to also multiply with the 1, which is just 6. Okay. Now, what I've just done is very similar to what's over here. You probably see some similar numbers here and there and wondering, hey, where did some of these numbers come from? I'm essentially doing the exact same thing, just in a different algorithm, more like left to right than up and down. And if I add these up, if I take 600 plus the 20 plus 180, that's going to be 800 plus 6 more. That's 806. So I get the same result. So this has a special name. It's just called foiling or multiplying two binomials. And we'll talk more about that in class. There is an area model that some students do like where you could think of if this was a rectangle. Okay. And if I were to break these into pieces and say, okay, what if I wanted to find the area of this rectangle, I would multiply this side by the other side. Well, let's call this side 30 and 1, and this piece 20 plus the 6. Okay, so I've done the exact same thing, and now I'm just going to be calculating 4 separate areas is all we're doing. Those areas, again, are the same numbers we just got up above. 30 times 20 is 600. 20 times 1 is 20. 30 times 6 is 180, and 1 times 6 is 6. So we would do the exact same thing to get the area of this rectangle. Remember, length times width. Once we multiply all these little areas, we can just add them up. So again, we would sum all those up and we would still get 806. So a bit of a visual way to see how things work. All right, let's do it with some variables. So again, I take my first term and I multiply it by both terms in the second polynomial, another binomial here. So my first multiplication with this arrow is representing c times c, which is c squared. And my second multiplication is going to be c times -7, which is going to give me a -7c. We always put our numbers in front and careful with signs. Next, we are going to multiply the second term, which is +3 times c. And that's going to give me a +3c. And then +3 times -7 is going to give me -21. Now we're almost done. We did do all of our 4 multiplications. Now you notice I can't just add or subtract all these together because they are not like terms. So a reminder is a like term must, or like terms, I should say, must have same variables with same exponents. Okay, so if I look across here, I do have a c squared, and I have a c to the 1 here, and another c to the 1. So these two middle terms are both c to the 1, same variable, same exponent. I can combine them. They are like terms. So all I have to do is, I can't combine it with the c squared because of the 2 here. It's not a like term. But these two I can combine. -7 plus 3 is going to give me -4 c's. Okay, and I still have the subtract 21. And we're done. All right. Let's tackle this one here. I got a couple different variables. I do have an x and a y this time. Now, we cannot use any exponent laws here. I don't just bring this 2 in. All it's saying is write it twice. Okay? It's this 2 represents, write it twice or multiply it. Okay? Lots of students think they can use an exponent law here, okay? You can't because of this subtraction. So all we're going to write is the exact same binomial twice being multiplied. Once I write this out, 2x minus 5y times 2x minus 5y, we can multiply this out. Again, first term times this first term is going to give me 4x squared, and 2x times the -5y is going to give me -10xy. And we're going to go down below this time, and we have -5y times the 2x is again going to give me -10xy. We write it always alphabetical. We don't write it as yx, we write it xy. And then we go -5 times -5y is going to give me +25. Y times y is y squared. Again, we notice that I have happened to come across our 2 like terms are in the middle again. We have an x to the 1 and a y to the 1, x to the 1, y to the 1, so those are considered like terms. So let's combine everything now in our final answer. The 4x squared doesn't change. -10 and -10 gives me -20xy's plus 25y squareds. All right, what if we have something that looks a little bit more complicated, like a binomial with a trinomial, or maybe even multiplying 2 trinomials? We do the exact same thing. We have to multiply every term in the first bracket, must multiply with every term in the second bracket, okay? So think of this as 2 groups, and I have to multiply every term in each of these bracketed groups by the other terms in the other group. Okay, so let's do this. Let's go back to red. So my first term is an x here, so I have to make 3 multiplications. I have to do 1, 2, 3 multiplications. So this first one is x times x squared is going to give me x to the 3. Okay, using our exponent laws. 1 plus 2 is 3. X times positive x, or positive 3x, is going to give me positive 3x squared. X times -7 is going to give me -7x. Now, let's take the -2 and multiply it through. -2 times x squared is going to give me -2x squared. -2 times positive 3x is going to give me -6x. And finally, -2 times the -7 is going to give me plus 14. All right, now we do have a few like terms here to deal with. So I can just work my way across. There's no other x cubes, no x to the cube, so that one doesn't have any friends. But this 3x squared does have a buddy. So I'll do a little squiggly line to show that these two are like terms. Okay. And as I work my way across, I see, oh, yeah, there's an x to the 1 and an x to the 1 here. So these as well are like terms. The 14 is the constant. There are no other constants to combine it with. So we can finish off this with combining these two pairs of like terms. So my x cubed stays. My positive 3x squared with my negative 2x squared is just 1x squared or just x squared. Okay, so then I like to cross those off when I combine them. Negative 7x with negative 6x is a negative 13x overall. Cross them off. And finally, I still have the plus 14. And now we see a nice polynomial in descending order, meaning the highest exponent of 3, 2, 1, then the constant. This is how we'd like to write our polynomials. All right. What about, let's do something as big as I'm going to ever give you, which is a trinomial times a trinomial. So I'm going to try to stay as organized as I can here to make it clear. But first, I'm going to take this first term, p squared, and multiply it by all three terms in the other polynomial. So I'm going to go p squared times 3p squared. That first multiplication is 3p to the 4. P squared times p squared is p to the 4. Our next multiplication is going to be p squared times negative 5p, which is negative 5p to the 3. And finally, p squared times negative 1 will be just negative 1p squared. All right. To keep track, I'm going to go to blue. This is going to look a little bit strange, but I'm going to start with positive 3p here, and I'm going to go up and down to multiply it with this 3p squared, which is going to give me positive 9p to the 3. I'm going to multiply again right here. 3p multiplied with negative 5p is negative 15p squared. And finally, 3p times the negative 1 is going to be negative 3p. One more to go. Let's switch to green. I'm going to be taking my negative 7 now and multiplying it with 3p squared. That's going to give me negative 21p squared. Then negative 7 times negative 5p is going to give me positive 35p. And negative 7 times negative 1 is going to give me positive 7. That's my constant. So let's be really careful working our way across here. Let's find all of our like terms. So p to the 4 has no friends. I know there's no other p to the 4s, so let's not worry about that one. I can right away write it down below. My negative 5p to the 3 does have some friends. So there's one here and one here. And working my way across, no more p to the 3s. There's a p to the 1, p to the 1 here. That's it. So let's combine them. Negative 5 plus 9 is going to give me positive 4p cubes. Okay, I'm going to cross them off so I don't have to pay attention to them anymore. Let's cross off the first one as well since we did that. All right, I got another pair of like terms here. I actually have triple. I have a negative 1p squared, a negative 15p squared, and a negative 21p squared. So I got to combine all three of those, and that's going to give me negative 37p squareds. Cross them all off now that I've accounted for them. And I have another pair, my final pair of like terms, which is negative 3p plus 35p is going to give me plus 32p to the 1. And cross them off. I have my only term left. That's why we cross things off is plus 7. And there's the biggest one I'm ever going to give you is we end up with a 5-term polynomial. Okay. Moving on, let's do ones with what about if I have more than 2 polynomials, okay? Now, again, I'm not going to push you past 3 because if you can do 3, I know you can do 20. So let's deal with these two here. And this is a longer set of notes being our first lesson of this new unit. So it's always good to pause when we have these longer ones, but we're going to finish this last page. When you have 3 terms, just take it 2 at a time. Do not try to multiply all 3 at the same time. So just do 2 polys at a time. Okay, do not try to do all 3. So I'm just going to deal with these 2 binomials. I'm going to leave this 2x out in front. So I'm actually going to write it right away. 2x is right here. And then in brackets, I'm going to put all of my terms that I get here. So I'm going to multiply x times x to get x squared, x times 5 to get positive or plus 5x. And I'm going to go underneath. 1 times x is going to give me plus 1x, and 1 times 5 is going to give me plus 5. Now, again, I do have like terms here, so let's combine those 2 in the middle. We have the 5x and the 1x right here, and right here, we're going to combine them and rewrite. So I still have my x squared. Put those 2, 5 plus 1 is 6x plus 5. And now we can multiply. I should have left a little room, but I'm going to multiply this 2x now in and finish it off. So when I do that, 2x times x squared is 2x cubed. 2x times positive 6x is 12x squared. And 2x times 5 is going to give me plus 10x. No more like terms. We are done. All right, let's try this one out. So again, this just means write it 3 times. Do not use any laws, okay? So we're going to take that, we're going to rewrite it as 2r minus 2, 2r minus 2, and 2r minus 2. Again, we're just going to deal with 2 things at a time. So I'm going to deal with these last 2. So I'm going to write my binomial that I'm not touching so I don't forget it's there. In brackets, I'm going to collect all of these. So 2r times 2r is 4r squared. 2r times negative 2 is negative 4r. Then negative 2 times 2r is negative 4r. And negative 2 times negative 2 is plus 4. Again, we're going to combine like terms. So I have 2 of them. It is this one and this one. So that's going to combine to give me negative 8r plus 4. Okay. And I'm going to be writing over top of this, but now I can finally take this binomial in front and multiply it with this new trinomial. So the 2r is going to multiply with 4r squared. That's going to give me 8r cubed. 2r is going to multiply with negative 8r, which is negative 16r squared. And finally, this 2r is going to multiply with plus 4, which gives me plus 8r. Now let's multiply the second term through. I'm going to take the negative 2 here and multiply it with 4r squared. That's going to give me negative 8r squared. And negative 2 times negative 8r is going to give me positive 16r squared. Excuse me. And then negative 2 times my last number, positive 4, is going to give me negative 8. Almost there. We're just going to combine a couple sets of like terms. I have an r squared and an r squared here. I have an 8r and a 16r. Oh, sorry. Let me just double check. Looks like I might have made an error here. Just double checking. Yes, this negative 16 should not be an r squared. Okay, sorry about that. I knew something was up. Let's just carefully erase that. Looks like I accidentally erased a bracket. Okay, let's finish it off. 8r cubed, and let's combine negative 16r squared and negative 8r squared. That's going to give me negative 24r squareds. Cross those off. They are done. And positive 8r plus 16r is going to give me a positive 24r to the 1. And finally, cross them off. I have just the negative 8 left over. And we've accounted for everything. I have 4 terms in my final answer, and double check my notes. That is correct. No other mistakes. Finally, you will deal with some slightly more challenging area questions. Now, just remember that area is really simple. That is length times the width. So we need to find those distances. And in this case, the distances of these two rectangles, I have a large one, okay, and a smaller one inside here with dimensions given as binomials. So how do we figure out the area of the shaded region? How do I figure out this portion here? Well, pretty simple actually. Just think of it like a cookie cutter. If I take the area of the large rectangle and subtract the area of the little rectangle, well, that will kind of cut out the inside and I'll be left with this border shaded area. So again, all I need to do is find area of the large, and I'm going to subtract the area of the small rectangle. Okay, well, let's actually write this out. So my large is going to be this times this. Okay, so I'm going to take my large and I'm going to write it as, excuse me, x plus 1. That looks like the width multiplied by the length, which is 2x minus 2. And then I have to subtract the small, which maybe I'll switch colors for the small. The small is going to be another 2, which is x minus 1, multiplying with x plus 2. Now, just when we're doing this, be careful of this negative. So I'm going to multiply out my red portion here, my large portion. Let's see what we get. X times 2x is going to give me 2x squared. X times negative 2 is going to give me negative 2x. Plus 1 times the 2x is going to give me 2x. And 1 times negative 2 is going to give me negative 2. I'm going to place that all in brackets because that is the whole large put together there. I'm going to rewrite it now and combine those like terms, but check out what happens. Those like terms are actually going to cancel each other out because negative 2 plus 2 is 0. So that term's going to go away. So all I'm going to have left is 2x squared minus 2. Okay, let's make this black as well. There we go. All right, let's deal with the green. All right, so I'm going to be subtracting everything in here. So this is x times x is x squared. X times 2 is plus 2x. Negative 1 times x is my is negative 1x. And negative 1 times 2 is negative 2. Okay, so again, I didn't draw it this time, but I think you're getting the idea. We multiplied here, here, and then here, here. Same thing just happened here. We're just doing 4 multiplications with the 2 binomials. Let's combine like terms for this one. So my x squared stays, and my plus 2x minus an x is going to leave me with just plus 1x minus 2. All right, now don't forget, this is where students slip up all the time. I'm taking the large area, which is this 2x squared minus 2, and subtracting this whole polynomial, which means I have to distribute this negative. Goes here, here, and here, because I'm subtracting all of those, which is just going to change the signs. So let's rewrite this. The first can come right out of the brackets because there's nothing in front here changing anything, multiplying a negative. But this negative multiplies in here, which makes it subtract x squared, subtract 1x, and add 2. So notice how my signs all changed from here, here, and here. Now we just got to combine like terms, and we're going to be finally done this last question. So I have a like term right here with this one. So I have 2x squared minus an x squared. That's going to give me just x squared overall. Cross them off. And I have a minus 1x here with no friends. So again, I'm just going to write minus 1x. And then I have a plus 2 constants here with a negative 2 with a positive 2. Those cancel to 0. So this is actually my final answer, x squared minus 1x, or x squared minus x. And that concludes this longer lesson. Okay, I apologize. This is a longer one, but just to review, we are basically remembering what a polynomial is and how to multiply polynomials together, combining like terms. Okay, we'll see you in class. See you next time.